Now the last thing that we're going to talk about in this section, so this is finally the last video, and that is going to be our distribution shapes. All right, so we're going to talk about some of the shapes that we can have of what some of the frequency distribution may look like and what are some information that they can tell us about where our mean, median, and mode may occur or may fall. All right, before we go ahead and talk about what some of these shapes may tell us with our mean, median, and mode, I first want to talk about what these shapes might look like. So if we say that we have a right skewed distribution, so let me just type this out. So a right skewed distribution, or if they say that it is a positively skewed, right? What this shape will look like, it means that most of our data, when it's right skewed, it means that most of our data is actually falling to the left, and it means that then some of our data is over here to the right. So it means that the bulk of our information, bulk of our data is actually to the left. So when we say it's right skewed, that is then telling us that the bulk of our data is to the left, and then we have some of these classes that might have some smaller frequencies to the right. So it's telling us where the lesser of our frequency is actually located. So then if we then have a left skewed or a negatively skewed distribution, what this is telling us then is that when it's left skewed, that means the bulk of our information or the bulk of our data will be over here to the right, and then we'll have some of our smaller frequencies will be over here to the left. So it's telling us when it's left skewed, it's telling us where the lower frequency classes may occur. So when it's left skewed, you might think that that's where the bulk of your data is at, but it's actually the opposite. We're looking at where there's little information or where our frequencies might not have as many as the other. And then if we have a symmetric distribution, you should know what symmetrical means. So that means that we have equal on both sides. So if we have symmetrical distribution, then it could look something like this, where we have the same kind of data. If we were to draw right down the middle, that it's symmetrical to each other, that if we fold it over top, that it will be exactly the same. All right, so that's what these distributions may look like. Right skewed, where bulk of our data is to left, left skewed, where bulk of our data is to the right, symmetrical, where it's even on both sides. All right, so let's talk about where the mean, median, and mode may fall for each of these. And before we do that, though, you might also remember that when it says right skewed, that is actually telling us where our tail is going. So here we can consider this the tail of our material. So when it's right skewed, it's saying the bulk's to the left and our tail's to the right. When it's left skewed, our bulk's to the right and our tail's to the left. So it could be thought about of where our tail is facing of our data. All right, so when we have a positively skewed or right skewed distribution like we do here, our mean will always be to the right of our median and our mode will be to the left. All right, so when we have a right skewed or positively skewed distribution, we know that this is how it's going to occur, that our mean will be to the right of our median and our mode will be to the left. When we have a negatively skewed or a left skewed distribution, here our mean will be to the left and our mode will be to the right. So you see when we change, whether if it's right skewed versus left skewed, our mean and mode switch the side that it will be located on about our median. When it was right skewed, our mean was to the right. When it was left skewed, our mean is to the left of the median. When it's right skewed, our mode is to the left of our median. And when it's left skewed, our mode will be to the right. And then when it's symmetrical, the mean, the median, and the mode will then appear in the same spot of our distribution. So they will each be in the same class and each be in the same class boundary, class limit of our distribution. So it's just some of the information you also need to know for this section. That's it for this section.